right, so we're going to talk about volume of the 5 solids that I introduced you to at the beginning of the year. So if you remember, it was in chapter 1, the last thing in chapter 1, we were talking about parts of three-dimensional figures. So we talked about prisms, cylinders, cones, pyramids, and spheres, and we labeled all the parts. Trying to ring a bell, maybe? It's been a long time. Okay, so we're going to be finding the volume of all those shapes today. Okay, so all the formulas are on your notes, obviously, but they are also on that formula sheet I gave you last week when we were doing surface area. Okay, so they're all on there as well. So we're going to start with prisms. Okay, so to find the volume of the prism, the formula is area of the base times the height. Okay, so capital B stands for the area of the base. The height refers to the distance between the two bases. Okay, so in this case, it is a vertical measurement, but it doesn't always have to be vertical. And I'll show you that in a minute. Now, when you first started learning volume, you probably just said length times width times height, which is fine for a rectangular prism, but the problem is we could have a pentagonal prism, we could have a hexagonal prism, we could have a triangular prism. Okay, so area of the base times the height covers everything. But quite frankly, if I saw a rectangular prism, I would also just think length times width times height. Okay, so that'll work for rectangular prisms. So let's go ahead and do this. So volume equals the area of the base times the height. So the area of my base this time it's a rectangle, but I just do 24 times 20. And then my height is going to be 10. And in this case, all those numbers are interchangeable, right? Because multiplication is commutative. All right, so when you multiply it all together, what do you get? 4,800. So we have 4,800 cubic centimeters. Good. So the volume, we're talking about filling up an object, right? Surface area, we're talking about the outside. Volume, we're filling up the object. So we're saying that it takes 4,800 cubes that are 1 centimeter by 1 centimeter by 1 centimeter to fill up that object. Is that okay? All right, so that's kind of old school. We've been doing this forever. Here's how we kind of step it up, though. I know one of your measurements didn't come through very clear on the copy machine, but all sides of the triangle are 8 units long. All right, so it is a prism. It's a triangular prism. What shape is my base? It's a triangle. It doesn't matter what it's sitting on. Okay, the bases have to be polygons. There have to be 2 of them. They're going to be parallel and congruent. So the triangles have to be your bases with a B. The faces with an F, faces, on any prism are always rectangles. So if you have something that's not a rectangle, that's going to be your base. Okay, so we know volume equals area of the base times the height. This time my base is a triangle, so it's 1/2 base times height. Let's multiply that by the height of the prism. So we need to think about the area of that light blue triangle there. Okay, so I need a base and a height. Well, what kind of triangle is this blue triangle? It's equilateral. So I can draw in a height here. If I draw in a height, what have I created? What kind of triangle is this? It's a 30, 60, 90 triangle. We got 30, 60, 90 triangle there. So my hypotenuse is 8. What's my short leg? And then my long leg is 4 radical 3. Good. So let's fill in what we know. We have 1/2. What's the base of my triangle? 8. The height of my triangle is 4 radical 3. And then the height of my prism, so the distance between the 2 bases is the height. So that has to be 10. All right, so 1/2 of 8 is 4. 4 times 4 is 16. 16 times 10 is 160. Radical 3 cubic units. You can multiply that all out as well if you like. Questions on the prisms?
So you said the faces are always rectangles.
Faces always have to be rectangles.
Like face and hat.
Yes.
Okay.
Yeah, I know it's so hard, especially with masks. So the faces are always going to be rectangles. The bases with the B can be any polygon. And remember, we name it by its base. So if it's a triangular prism, that means the base has to be a triangle. If it's a pentagonal prism, the base has to be a pentagon. Are we good? All right. Next shape is a cylinder. You'll notice we have the exact same formula again. Area of the base times the height. But what's my base always going to be? It's always going to be a circle. And I can find the area of a circle with pi r squared. Good? All right, so let's do it. So volume equals area of the base times the height. This time my base is a circle, so it's pi r squared times the height of the cylinder. So I have pi times, what is my radius in this case? 100. So pi times 100 squared times the height, which is 25. I'm just going to leave it in terms of pi. Going to take 250,000 pi cubic feet. Excuse me. Okay on that one? All right, so the only little spin I can put on it would be if we have something called an oblique cylinder. So an oblique cylinder, have you ever taken quarters or any kind of coin, really? You put one down, then you take the next one, you stack it just a little bit more to the side, the next one is a little bit more to the side, and it makes like this leaning tower. If not, that's one of your homework assignments tonight. Okay, make yourself a leaning tower of coins. Okay, it's called an oblique cylinder. All right, so the base is still the same, still a circle. The height is going to be the distance from between the two bases, but we're not talking about this slant height here. We're talking about like the actual altitude. Okay, so the equations would be exactly the same. Area of the base times the height. So pi times my radius, this time is 6 squared, and the height for this cylinder is 7. So 36 times 7 gives me 252. So 252 pi cubic units. All right, so those are our shapes with two bases. Prisms and cylinders, they have the exact same formula. Just got to think about the area of the base, right? Okay, now we're going to deal with the shapes that have just one base, so pyramids and cones. So the pyramid, the volume is 1/3 times the area of the base times the height. Again, my base for a pyramid can be any polygon. Any polygon. So here we go. My base in this case happens to be a square. So volume equals 1/3 area of the base times the height. So that's 1/3. The area of my base is just going to be 8 by 8. And then the height of my pyramid, we're talking, the height, remember, is always from the vertex straight to the base. We're not talking slant height like we were with surface area. We're not talking about like sliding down the side. We're talking the actual height. So my height here is 12. We multiply that all together, we get 256 cubic units. All right, good news is we have the exact same formula for cones. 1/3 of the area of the base times the height, except what's my base always going to be with a cone? A circle. All right. So here we go. Volume equals 1/3 area of the base times the height. So my base is pi r squared, so pi times my radius squared, so 3 squared, times the height of my cone. Again, we're talking about the axis altitude, right? Straight down, so that gives me 8. We end up with 24 pi cubic units. Good? All right. Last shape then is a sphere. Okay, so no bases on this one. So our sphere, the formula is the volume is 4/3 pi r cubed. 4/3 pi r cubed. So in this case, oh, let me touch it. In this case here, my radius is 8. Okay, so really there's not a whole lot to calculate on this one. This one does not simplify nicely either. So if I multiply my numerators together, I end up with 2,048 pi. That's all over 3. Cubic centimeters. I don't care if you want to put that in decimal, whatever floats your boat there. So the volume that we're really going to be working with is fairly straightforward. On the air test, you are given all the volume formulas. You're given the area of a triangle, the area of a circle, the area of a parallelogram. Surface area is not supposed to be on the air test, but I felt wrong as a geometry teacher not teaching surface area. It just seemed weird. Okay, so that's why we threw that in as well. And it's going to help us at the end of the year. So that's why I kind of want to do a quick review of all the volume things. Okay, so I have a homework assignment for you today. I need to, I'll pass it out and then I need to give you one correction.